Okay, so I might kick off. Most people are in the room. We seem to have reasonable attendance based on registration. So again, thank you for joining us on this session. Um, we quite often get asked about designing bus bays and parking bays, and it's always an interesting discussion about what people want out of designing a bus bay and a parking bay. Are they looking to just extend out to some cross sections where the bay is wider? Do they want to independently design the edge of the bay? Is it a nice smooth entry and exit, like for a bus entry and exit into a side area? Or are we talking about 60-degree or 90-degree angle parking bays? And they all need a different treatment. So we thought we'd put on this session to show people different techniques for dealing with parking bays for three purposes: cross-section plotting, modeling, surface modeling, and also surface visualization. So there's sort of three different considerations to make depending on what you want out of designing a bus bay and a parking bay. Okay, so please forgive me if there is much coughing and much spluttering. I am suffering from a cold. I promise that I won't pass it to you down the line. What we're going to do is just kick off through a quick PowerPoint, and then I'll sort of get in and start talking to you about the details. Okay, so firstly, when it comes to parking bays, there's a number of different options for parking bays, and I've unfortunately destroyed my slide where I talked about the different options. But basically, you can have parking bays where you just widen out onto alignment, and they will work for you, as I say, if the entry and the entrance is smooth. And then you've got two other levels of designing parking bays using a knuckle approach, which does an independent design of the bay, or using a pure sort of independent bay design. So I'm going to take you through those four options. There are four options that I have for traditional parking bays. So without the introductory slide, let's just kick in. So let me chat with you about four different options for doing parking bays or bus bays. So look, parking bays and bus bays really is any sort of widening. It doesn't have to be the road pavement. You might be widening out a footpath to duplicate footpath part travel ways, or you could be doing it for all sorts of reasons. But the most likely is you're trying to widen out the road pavement. Difference between a parking bay and a widening for a lane really is that parking bay is closed and the lane sort of continues the extra width. Option one is the simplest, and all you're really doing in option one is you're taking your traditional road cross section and you're widening it out. And the only thing you need to do that is an alignment. We recommend an alignment because then you'll get your sort of curved transitions going on. If you are using Civil 3D, there's some nice offsetting tools, and otherwise it's quite easy to make an alignment. Where this situation doesn't work is when you have excuse me, dramatic direction changes. So 90-degree parking bays, 60-degree angle parking bays. Those parts of the cross section where you're going out that 90 degrees or you're doing the 60-degree return, they don't work at a cross section level. Moving on from there is option two. So this sort of suffers the same fate as option one in that it works very well for a bus bay where you have a nice sort of transition in and transition out. The difference between this and option one really is that you're governing a crossfall change at the bus bay, and traditionally you put in a dish or something like that. So this is what I would call a cross-sectional approach to parking bay design, and I'll show you some tricks to make this happen and how to put it all together. And again, it looks like I have failed here with being paused. Apologies, everybody. Let's roll back to option 1 here. So thank you, everyone, for letting me that I've muddled around with the slides. So you should be seeing this picture of option 1. Option 1 is just widening out the road pavement, as I said. Straight stretch out, no crossfall adjustment between the center line and the road edge. Option 2, as I said, is similar to option 1 in that it's cross-sectional based, but you're working in a different zone because you're trying to introduce some sort of dish channel, some sort of grade break or change. That may be a dish, it may just be a single grade break line, you may be going up, you may be going further down. This method also blends really nicely for independently designing the bay itself as a string, in which case you can independently grade it vertically. But it's based on cross sections hanging off just the one main road center line. Now we move into what option 3 would look like. In option 3, you've got that more severe sort of change in the parking bay shape. So if we have a look at that image, it's sort of showing a 60-degree angle parking bay wrapping back upon itself. Now, the cross sections would look really good off the road before this return, but through this return area, the cross sections would not look very good at all because you can't hang cross sections off the road against sort of one perpendicular line. There's a tool called a Knuckle. If you haven't used it, what it does is it removes the road from a certain code outwards and lets you replace it with your own alignment and also your own cross sections. Now the benefit of this is that you then can design this widening with its own cross sections perpendicular to the run of that alignment, and that gives you the opportunity to do this wraparound. So Knuckle's nice because it's simple in that it tidies up the model for you. It cuts the road out and puts the knuckle in. It is also great because it automatically sort of captures the road elevations going in and going out of the knuckle, much like a curb return, and it lets you then independently design the knuckle itself. Now there are some rules around that, so there's a bit of play when you end up into this sort of return area of your knuckle. But we'll talk about that. So this is option 3, what we're going to look at. Option 4 is really the do anything you want, however you want scenario. And we actually see this quite a bit where there's a whole series of indented parking bays that are happening along a road. So if you look at the plan up the top, this is a plan view showing that you've got sort of some 60-degree angle parking bays and then some 90-degree angle parking bays. Now, in order to get the flexibility to do this one, what you really need to do is to consider the parking bay alignment as its own string, and it has its own cross sections, normally just holding the curb. The footpath can come off the bay string, or it can actually come off the main road. And in our case, we're definitely going to take it off the main road because it sort of runs more parallel to the main road than it does to the parking bays. But we're going to build ourselves up to bay option 4. Essentially, you trim out the road, you put in your dish, and then you'll have an independent string for the parking bay. There's a really cool set of tools to get some elevations that are reasonable. You can use a tool called Surface Extend. So if you haven't used that tool, it can be very helpful to establish some good elevations for parking bays. So there's sort of the 4 options that I want to put in front of you about doing parking bays. I will come back to this slide just to talk about cross sections, but let's get in and start looking at using the software. Okay, so option 1. Option 1 is us doing a very simple stretch out of a bus bay. Now, we only need one template for this. We actually can get away with one template for the whole job for all the scenarios, unless you want subgrade, and then we need to do some other templates. There's already some alignments drawn, so I'll talk to you about these alignments as we go, but here's an alignment that is an offset alignment from the Civil 3D centerline. So the great thing about offset alignments is this sort of grip edit capability. and it tracks what's going on with the main alignment. So if you have never made them before, you run the offset alignment command, and off you go. Let's go ahead and make a road. So in order to make the road, I need a template. Now I've created some templates in preparation for today, but we're going to start with the very standard metric 6 meter template. Okay, so it's got curb, barrier curb, footpath, and pavement. So we're going to create the road. Now I'm doing 10 meter sampling. What I'm going to do straight up is to add extra sampling. So I'm going to tell the software that I'm interested in giving cross sections every meter. Now I'm doing this in preparation for improving the modeling of the bay here, because we only model as accurately as we cut cross sections. So I'm going to close the tool space just because I know we're going to be squished for real estate. Okay, so this is the vertical grading of that road. As you can see, it's just a straight line run. If we just quickly open up model viewer so you can see the development of things. So I'm just popping open model viewer. Okay. So this is the road as it is. Very simple, one set of cross sections applied. So in order for us to make a change, we're going to make use of this alignment here. So if I just pop a cross section around where that bay is. So here's my current cross section shape. I will turn on codes because I like seeing the codes. And what I'm going to do is go straight into the design data form. So the design data form is where you execute changes to your cross sections. And we've got a whole raft of options here. One is to change template. But in our case, if we go to variations, there's a very simple variation called set code offset to alignment. So all we need to do is grab the relevant code, that is REB, and we say, we'll be lazy, for the whole length of the road, let's widen out. We'll keep the crossfall at -3%, and we're going to hop onto this bus bay right-hand side alignment. Okay, so you'll see that the cross sections are now widened out, and as I sort of spill through those cross sections, you'll see it gently returns back. As soon as I force an update to the model, then model viewer will react to that change, unless I've somehow told it not to. So we can see in here now that we've got that bay widening going on. Now it's just a straight widening. If I look at the wireframe view, it's just straight out. There's no grade break or change to that level. So let's have a look at option 2, where we actually want to enforce a grade break. Okay, so if I step back to the slide for a second, you know, we're looking at forming up a dish and pushing out a bus bay at let's say 3%. So what's the best way to do that? You can certainly add extra codes, or you might go for a different template. So I'm going to take the option of going for a different template. Now, it's a great idea to have an alignment ready to go. So I've got an alignment here called bus bay left-hand side. And again, if you look at the controls on that alignment, it's an offset alignment, so it's tagged against the main road center line. But let's have a quick look at our options in terms of templates. So I'm going to open up the template editor. Now there's two ways to do this. Do you want to create then destroy, or do you want to just create on the fly? It's a weird thing to say, but what I'm going to do is to do the create and destroy method. I actually have a template that I've built here called, I'm just going to find it, local road with bus bay left hand side. Now I just want to focus on the left hand side where I'm setting up for a bus bay. So what I've actually got here is the edge of bitumen, then there's an invert, which I've called LINV, and then I've got a new code called LBK2. So that's this guy here at the back of the dish. And really sneaky, I've added in an extra code called LBay for the parking bay widening that I want to have happen. Now, should I set that to plot? Maybe. Then it shows up on the cross sections when I go to plot offsets. But I've just put it in, and it's only 1 millimeter wide, so it doesn't really get in my way until I actually put it on alignment. Just after the L bay is the top of the curb and the back of the curb. So if we simulate the left bay moving out by 2 meters, that's what's going to happen. Okay, we're going to push that out by 2 meters. We're going to have curb on the left and curb through the dish. So I'm creating all this content, and then I'm going to apply it. Right, so what I'm going to do is to change the template in the zone of where this bus bay is. Now, in terms of getting things exactly right, if we think about the sampling, wherever you sample a cross-section is where you can execute a change. So I'm going to be introducing addition here. So I can see that there's a 300mm offset at this location. If I imagine a dish being another 300, I can sort of eyeball where it would intersect with the alignment. That's sort of where my dish would start. So what I'm going to do is to force in some extra cross sections. And there's a couple ways to do that. You can certainly do it from the vertical grading editor or the design data form, or there's a command here called add extra sections. So just quickly, I'm going to push into DeLorme Street some extra changes. I'm going to, it's telling me it doesn't want to, back in. Okay, so we're going to add single change. I'm going to pick here at the start of the alignment, add a single change also at, if I imagine 300mm offset, probably around about, there's probably already one there, that one's probably good enough. And I'll check out if I need to add cross sections here, so 300mm off from there, it probably falls about here. Okay, so you can see I'm just forcing in change exactly where I want change to happen. Okay, let's have a look at building this up, right? So what we need to do is to change the template. That's our starting point. So we're going to go into the design data form for DeLorme Street. And in here, I'm going to change the template around. So I'm going to stop the template for the bus bay. And then what I'm going to do is to add a new template from change 9, which is where the last one finishes, up until the end of the bus bay. Okay, and I'm going to apply that different template that we wanted. So we're looking at barrier curb and we're looking at road with bus bay. So if I just quickly build this, have a look at the sections here, you can see that the road's much shorter and that we've actually got a section built up here with a dish. I'll just change the exaggeration to 2. Make it a bit more severe so we can see. But you can see that there's a formed up dish now happening from change 9 to change 65. Let's put our other template back. So we're going to go from 65 to the end of the road, and we're just going to do the metric road 6 meter. So you may sort of be asking why I bothered with the template. The only reason that I bothered with the template, didn't use my usual trick of inserting codes. One's probably speed. It's probably a bit quicker to add all those codes at once, but the other issue really is the subgrade. So that's the real reason why gone to the effort of putting in a different template. Now, if we think about the plan for a moment, I actually have an issue where I can see these codes. So one of the beauty of showing all the codes is that you can see them in the plan, and I can see that the back of this dish here is overlapping the alignment of the return, right? So before I even widen, I might as well trim up the dish. So the back of the dish, that would be this code here, really shouldn't exist past that point. So I'm going to go into the variations and start playing around with that. Now, in preparation for all this, let's add a comment field. So I'm going to put in a comment, and I'm going to say here, I'm going to put in capitals, this is widening with dish. I'm putting this in because if we come back later, we at least can then track what it is that we've done. And I'm going to put in here that I'm trimming back the dish. Okay, so what I'm doing is I'm going to add variation, and I'm going to use delete section. Okay, so, and I'm going to say from this point here where I can see that dish sort of hits the alignment, from that point to, let's go up here somewhere, we don't want the back of the curb, number 2, right? So when I add this, you'll see that when we look at the sections, that back of the dish is now disappearing. Now we can play around with the levels of it, play around with the chainage range of this. Maybe there's a closer cross section, and that is closer, but that's where the dish is going to finish. So let's fix that at the start as well. So we're going to just copy this entry, and all we're doing is we're changing the range. So we're going to say from 0 to where these two things intersect, so around here. Let's kill off the dish. Okay, so the back of the dish is gone in those zones. If I actually look around chainage 10, you can see that there's no back of the dish, and as I move through, then suddenly the dish will turn up. Okay, and that's what we want. We want that because our next step is to widen the alignment. So I'm going to add a little comment here. So widen to alignment for LPAVE or LBay code. So I've got this code for the bus bay, and I'm going to now widen that onto the alignment. So I'm going to set code offset to alignment, and I say for the left bay, wherever you find the left bay, I guess, but let's limit this 0 to 66. We're going to widen by changing offset and level, and we're going to widen onto the alignment that's here. And the alignment here is called parking bay left-hand side, bus bay left-hand side section control. So when I add this, now what I'm saying is, if I update my model, you'll see that that's now kicking out a bay. Now, the great news is that I'm guaranteed that that's at 3%, so no matter sort of what I do with the road, that's going to hold a 3% crossflow. Okay, and if I look at my cross sections in a bit more detail, as I sort of push through, you can see that bay is now widening out at that 3%. Now that all works really nicely because the sections are at a fairly acute angle relative to the center line. Once we get closer to sort of 60 degrees, 90 degrees, you start getting a distortion in the shape of the curve and the footpath because it's being measured from the center line perpendicular. But in this case, you can see that it's quite a nicely formed bus bay rolling out and rolling back. Okay, any change to the road design is automatically, the road center line that is automatically going to influence this whole lot, because they're all tied together just by sectional relationships. Okay, so that sort of sets up what I think is reasonable for a sectional design. It doesn't preclude you at all from using that alignment and putting on a string control. Okay, no problems with that at all. And you then set up the string to affect the bay code. But this is probably the sort of more simple setup. The only thing that I did notice on here, looking closely at it, and we're really looking very critically, is there's a bit of a jump where it suddenly transitions to 10% or 7.25% dish, or whatever that dish grade is. If you really wanted to be finicky about sorting that out, what you would do is to put on a linear vary. So this is real fine tuning stuff, but if I add in here a linear vary, I could decide that the back of the dish from wherever it starts, so I go and pick where it starts here. Let's add 2 meters, so let's go at say 16 or 15. We're not going to change the width of it over that range, but we're going to set the depth change. So the depth change to match about the 3% that's at this point is for us to go, that's about 100 mil up, and then it finishes at 10 mil. It finishes 30 mil up. So this would transition us from, if I look in here at change 13. So change 13, if I look closely at this, it's 3%. But suddenly when we get to 14, it's 7.5, 1 in 7.5. And that's what I'm trying to modify here. Once I click on Add Update, what you'll see now is that we're actually transitioning over the 2 meters from the 3% up to that 10%. And if I force a reboot in the model, what you'll see is that we're pulling out that abrupt sort of kink in the curve. Really subtle stuff, but if you're really keen on your model looking exact, you would consider doing this at the approach and at the departure of your base. Okay, but that sort of sets up how to do a sectional bay design. And as I say, it works quite well in the situation where you have a reasonable angle of entry and exit relative to the center line. Okay, so if it's fairly parallel like this. So when do we come unstuck? And we're now sort of thinking about option 3 here. So option 3 sort of comes into play when you do have 90-degree angle bays, or you do have 60-degree returns. And one cool tool that you can use to deal with that is the Knuckle tool. Now the Knuckle tool was actually built to do a localized widening. Normally one of those sort of pimple widenings that happens at a bend in a road to give more frontage properties. But if you have an alignment, you can make a knuckle. And so you can have any shape you want hanging off the edge of a road, and that is treated as a knuckle. And a knuckle has a special purpose for a road string. It will cut up the cross sections of the road string from whatever code you pick on the road outwards and replace it with the knuckle. And the beauty of this is that it goes into total model. So you don't need to build your own model. You don't need to make sort of detailed adjustments in a modeling sense. Okay, so the knuckle automates the vertical design. The knuckle uses a code to cut and then hops in. I do have a note here, it can be tricky to include a dish. Okay, so I'll talk about that now. So I've got an alignment here that would really suit the knuckle situation. And I do apologize for my lack of real estate. But I've got an alignment here called parking bay widening, and I'm going to now use that to create a bay. Now, if you were to take an imaginary line through here, this would be what a cross-section off the road would see. It would see this code once, right, if you use this string to control it or alignment, and it would see it twice. Now, that doesn't work in terms of cross-sections, right? Cross-sections have one code seen once, so you wouldn't get this shape. What would happen is the software would take probably the closest alignment here. They would be the offsets for the curb, and then at this point it would then jump out to the maximum. So from a modeling sense, this part can't be modeled purely off the center line of the main road. You actually need another string. So a knuckle helps you design that other string. We're going to run the knuckle command. Now, I'm committed to us putting a dish in place, really just so you can see how to use a knuckle with a dish. The easiest way to create a knuckle is actually to link the knuckle to the edge of the road and not bother with a dish. All right, that's the simplest way, but we're going to put a dish in. Now, I've deliberately drawn my alignment to hang off the invert of the curb, because the invert of the curb is going to continue all the way down the road here unadjusted. Okay, so there's no point redesigning it. We might as well just use what the road's given us. So here's how to create a knuckle. We click on knuckle. I might just move this stuff out for a sec. We click on knuckle. At the command prompt, it says to you, hey, what do you want to do? Let's press escape to make a new one. So we're going to call this one widening right-hand side, and let's call it knuckle. We're going to get information off the lawn street, and we're keeping the lawn street all the way up to the invert. Okay, so the knuckle will be a string that connects to the invert of the road. If we then go to specify, we're going to pick our alignment that we made. Okay, so this is parking bay widening right-hand side knuckle method. Okay, so we're grabbing that particular alignment. You then click on Create Update Alignment. Now what that will do is it will pick up the alignment and make sure that it touches the invert of the road start and the invert of the road at the end. Okay, so from a plan perspective, it just puts it in place. When you look at the vertical information, here's where the knuckle's really interesting. You can not do anything vertically about the knuckle, or you can actually give it its own vertical design. So we're going to give it its own vertical design. This area here is talking about how the knuckle connects to the road. So from a vertical standpoint, when this string gets created, the knuckle string, it will attach itself to the road elevations at the start and at the end. This option is saying, hey, do you just want to take the crossfall of the road, maybe reverse it and run it up to form the knuckle? Okay, so it's actually giving you the options to reverse slope. Now the danger of this is just which code it's going to reverse slope for, because you don't really want it reversing slope for the invert. But we'll turn it on and let it do its thing. I'm not going to let it go very far from the start, so I'm just going to make this, say, 2 meters. In between 2 meters along that way and 10 meters back that way, you design it however you like. I'll make that 5. Now you've got a string sampling, so 1 meter sampling all the way around. Let's make that, say, 0.5, give us a bit of better curve bends. And we're going to attach a template. So think about this. The footpath and the curb is going to get removed, as well as the batter for the road. And you're replacing it with a string that runs around here, has a code that touches the invert of the road, and you decide what happens to the outside of that string. So you actually want to put something on there. I actually have a template called barrier, curb, and footpath. So all it is there's a center line, the barrier, curb, and then a footpath and a batter. So I'm just going to run that all the way around this parking bay. Okay, we're actually going to click on compute now, and this will do an independent string of this guy and cut it into the model. You'll see here about the widening. This is what you're going to do to the road. Nothing. You're going to take the invert code and stick it on where this knuckle is, or you're going to create a brand new code for the knuckle, which is exactly what we're going to do. When you go compute vertical grading, the software will actually do the job of putting that knuckle in place. So I'm going to close that out, and we're just going to have a quick look at some of the mess that we've made. But there's my knuckle, right? So you can see that there's some seriously overlapping information at the front here where the footpaths are having a war. But you can also see that there's clearly a dish happening in here. So we'll tidy some things up, and I'm going to take the cheap and cheerful approach to resolving this, which is just to delete where they overlap. Okay, but you might want to create an alignment and run the alignment for the parking bay out to here, and then run the road alignment. Actually, maybe that's the best way to do it. Maybe we'll just do that straight up. So I'm going to just quickly run an alignment here for my parking bay, sorry, for my footpath. So let me just quickly turn that into alignment. footpath fix up on the right hand side, so I don't forget what it is. Okay, so I normally run the alignment in the direction of the road, but that is fine. What I'm going to do now is go to the main road of DeLawn Street, so that's this guy here, and I'm going to tell it to use that alignment for the footpath. Okay, so I'll put in a comment here because we're in a new zone, so we're now dealing with the Knuckle. And I'm going to add in just a simple alignment control for the footpath. So what I'm going to do is take the right footpath inside edge, and wherever I find that alignment, I'm going to use the alignment to change the footpath offset. So that's the footpath fix up right hand side. Okay, so if I just build that, so that pulls this footpath out, which is sort of what I want, and then I just need to deal with this mess. Okay, so mess of my own making. I actually have a double up of footpath information. So what I need to do is get rid of the footpath off the Knuckle string. Okay, so I just go into the design data form and open up the Knuckle string. Okay, so the Knuckle was applying a template, so if I just quickly show you that, this is all the Knuckle is. It's just the curb and the footpath, and that gets run around the cross sections. Okay, and there's a massive overlap of the footpath up until about this point, 7.5. We want to get rid of the footpath. So to quickly get rid of the footpath, we're going to make edits to the Knuckle. So we're going to run a variation, and there's a cool variation called delete all sections outside selected codes. And what it lets me do is it lets me say from 0 to 7.5, let's remove everything. On the left side, we'll keep everything, so we go to L done, but on the right side, anything outside of RBK, blow away. Once I update this, you'll see that the footpath is gone. Now the daylight's still there, so I need to just tidy that up. So let's make this a bit, I don't know, 7.5 is right. I'm just going to kill off the daylight, so I go into the batters, and I say slope batter, and I say from 0 to 7.5, and I'm going to remove the batter. Now the way you remove the batter is by not putting in any inputs. What that does is effectively strips it out. Now, my footpath is unfortunately pushing back here because it still exists on the main road. So I just need this alignment to extend a bit further. I didn't do a good enough job on that. So I'm going to fix up the surface, and then I'll just tidy up my little error on my footpath, and we should be looking good. So if I go to the design data form for DeLawn Street, so what I just did was I stretched the footpath. If you are using threads, you can automate this update, but I just need to force an update on this sample, and then what you'll see now is I've got a fairly reasonable sort of design here. So there's my Knuckle in place. What I'm missing here though is the dish. Okay, so here's the trick with the dish. You have to realize when you look at your road cross sections, what's actually happened is the software, in order to do what you wanted it to do, it's gone and removed everything from the dish outwards and replaced it with a connection to the Knuckle. Okay, so that's what the Knuckle does. It removes the road, replaces it with a code to connect to the Knuckle. Now, we actually want to put in a dish here, so we have to fake in a dish shape before the invert. All right, so if I open up the design data form here, now we might need to add an extra section to make things cut in where we want, but we're now going to fake in a dish. So the way I do this is I use this command called insert section. And what I'm going to do is I'm going to get in the way of the invert where it hits the edge of the road. So on the right hand side, before the right invert, this code here, which is that one there. I'm going to stick in a new code called, I'll just call it RANV2 because I'm not very creative. And I'm going to do that where I think the dish could go. So it probably could go around here somewhere, and probably wants to stop somewhere around here before the return. And I'm going to give it a width of 0.3. I'm going to give it a vertical distance of minus 0.03. Okay, so I'm dropping down into a tray. When I update this, what you'll see is that it now inserts this new code. Okay, and that code only exists where I've got the cross sections saying that it should exist. Right? Now, if you do find you get an overlap, just come back in and change your extents. Right? I mean, I'm not too happy with that. What I could do is just come in and quickly say I want to add, let's say, 0.2 spacings from here to here, and that's going to provide a better sort of cut point. Okay, so when I OK this, that will make the model tighter, give me a better modeling outcome. Okay, but what you'll see now is that we've got no dish, right? We still don't have a dish. We actually have a constant fall. This invert is not falling the right way. So if we go into the design data form again, what we actually need to do is to take note that we put in this dish 180 to 206, and we actually want to flip the invert code to go from downhill to uphill. So we use linearly vary, and we take the invert code, and we say from 180 to 206, so where the dish has been inserted, set incrementally, don't change the width, so incremental change of 0, and then we're going to set the height to be 0.03 instead of minus 0.03. And when I update this, you'll see that the cross sections now look good here, and when I run the update on the model, you'll see now that we have a properly formed dish going on. Okay, so that's what I would be doing for the Knuckle approach. Just realize that I've certainly gone through and looked at my code grouping, and that's why, on the whole, I actually get a good looking model. You'll find that you'll get quite a few reds when you're introducing new codes, and all you need to do is you right click on the one that's red, assign, and you assign the material. Now, just realize that form goes behind others. So I don't really need to play with that at this stage. Okay, so we've actually done option 2 here. Just realize as well that this is concrete because it's back a curb, running to back a curb. You could fix that up from a modeling perspective by putting a little code in here called bat or batter, so that it did actually batter. Okay, I'm going to move on from here into option 4, which is the most versatile, but also got the most steps. So let me just introduce that again. So this is what option 4 looks like. It'll handle any shape you like. Basically what you do is you trim out the road, in a sense, where the curb is, and you replace it with a designed base string. So you have another string that you've designed with the curb on it that you want. You pull out the curb off the road and you replace it. That's sort of a simple sum up of what happens. How that actually works, there's 2 things you need to do. You need to create a string for the parking bay offsets. You need to set some levels for it and match it up to the edge of the road, and there's a really cool tool to help you do that. And then you need to cut it in to build a model. Right, so it doesn't automatically go into total model, but you can certainly cut it in. Once you've done that, you've actually built a surface model that you can then extract cross sections from when you do your plotting. If you do want subgrade, there's a bit of a trick, and I'll talk to you about that in a sec. Okay, so that's sort of option 4 overview. Just thinking about what you see on the screen there, you've got these parking bays. So there's one alignment that runs all the way around where this red stuff is, defining those offsets for the parking bay. And I'll just talk to you about how I've set this up so that you understand a neat way to model it. Okay, it's certainly not the only way, but I did find it to be probably the neatest way to make happen what I wanted to have happen. Okay, so I have an alignment here. This alignment actually cuts in at the invert of the road, because I'm happy to keep the invert going through. I want a dish, and then it rolls out, and then it rolls back in whatever shape you want, up to just a small smidge off the invert. So pretty much going back to the invert and then coming away, and then we're going back to the invert again. Now, just to keep it interesting, I've got some 90-degree angles here. I've got some 60-degree angle bays. Okay, so the shape could be whatever you want it to be. Now, what you need to realize is that what we're doing essentially is we're going to be sticking this design in between the current road, okay? And the current road has no dish at this stage, but we're going to put the dish in. It has a footpath, it has a batter. So the first thing that we will do is move the footpath away from the design we're going to stick in, and I have an alignment for that. So you'll see this alignment here for the footpath, and it sort of rolls around the back of the alignment. Okay, so I'm deciding where the footpath is going to go, independent, well, not independent, but thinking about how I want it to transition to the back of this alignment. Okay, now this starts just like option 2. We replace the template in here so that we've got a dish, and then we remove the dish where we don't want it happening. Once we've done that, we then use the alignment control to control this offset. Well, we could, but we actually need to create a string. Right, so there's a couple of stages in here. So we're going to prepare the main road. The things that are consistent on the main road is the invert and the dish, and also the footpath. So those things we set up on DeLorme Street on the main road. When it comes to the elevations of the parking bay and the curb that gets applied, that's actually going to come off this independent string. So we're going to use the road to establish some good levels, and then we're going to use the string to then set up what happens in between the footpath and the back of the dish. So I hope that all makes sense. So just recapping on this one, to start, we make some manipulations on the main road, and we do that by applying a different template. And just to reiterate what this template looks like, it already has a dish in it, and just to keep things interesting, it also has a 1 millimeter wide code called L-Bay at 3%. Now, what you need to know is that you can use any code that you like out of a road and extend that code outwards. So you'll see something pretty cool later on when we do the surface extend. We're going to be extending that L-Bay code out at 3%, and then we're going to drape our parking bay onto it. But let me savor that excitement for later. But there's a dish here. We're going to stick it in. We're going to kill off the dish where we don't want it, the back of the dish, and then we're going to work from there. Okay, so if we open up the design of DeLorme Street, that's right here. Okay, so I'll just add a comment just to separate out this discussion from the rest. So this is doing the string-based parking bay. Okay, so let's go and add our changes. So firstly, I'll just get rid of what I just do. I just deleted the entry I just added. That's a bit silly. A bit click happy, I apologize. Let's go string design. Okay, so if we scroll up the template, what we're going to do is to quickly sort out the templates. So we're going to stop the metric road template at this location, and we're going to then add in a new template to take over from 171 to the end of the bays. Right, so it's going all the way along that alignment up until here. And we're going to use the barrier curb road with bus bay. And then just to finish it off, we'll do a 374 to the end, and we'll go back to our metric. Okay, so if I just update the surface here, model builder will update. You'll see now that we have this little system in here. That red is actually because I've got the left parking bay on the back of curb 2 is next to the top of the curb. And you have to tell the software what you want to do in that case. I'm not going to worry about fixing that up until I've gone and sorted out everything else. But we've now got a dish that's turned up for the whole length of, or for a long length of that road. We're then going to set up the footpath. So let's go and set up the footpath, and then we'll get rid of this dish where it shouldn't exist. Okay, so to set up the footpath, we're going to use initially just an alignment control. So we're going to say take the left footpath and from, let's say here, a bit earlier, where's that alignment come back? That alignment starts there, so from this point to the end, we're just going to widen out the footpath onto the footpath alignment that we did. Where's the footpath alignment? There we go, the footpath. Okay, so what you'll see is that the footpath will now sort of kick out, and that's moving out to make room for the bays that we're going to stick in the gap here. Okay, so just to keep things neat for us more than anything else, but we've sort of pushed that out to make room for those bays. Okay, so this dish though, the back of that dish shouldn't exist everywhere. So you can actually see this first instance where the dish has gone in. Okay, so you can see that dish line. If I stop this command, you see that dish line's in there, and it cuts over the top of this alignment. So we're just going to sacrifice out the dish where it shouldn't be. In preparation for that, I'm going to create some cross-section changes at those spots, just to make sure I pick up sort of where I want trimming to happen. So you see I'm rolling down here, I'm just adding trim points where the dish sort of cuts against the parking bay, because both of them can't exist at the same time. And then I'm going to use those to form up deletes. Okay, so where that white line hits up the bay, where the bay goes in front of it. Now, if you weren't as gung-ho as me in pushing the bay alignment right up to the invert, maybe the dish just continues on unchanged, in which case this part of the process you wouldn't have to do. Let me just set this up quick. That one's actually not too bad. Yeah. Now, just as a belt and braces, I'm going to just flood this with sections. Probably could have done this directly from the alignment. So pick alignment for extents. So I'm going to grab this alignment here and use it to flood 0.2 meter interval sections. So I've now got like a heap of sections in here. If I can't find one I like, then there's something wrong with me. But what I'm going to do is to start cutting out the back of the dish where it shouldn't exist. So I'm trying to get rid of these conflict points here. So I'm going to add in delete section, and I'm going to go from here, wherever this is, to an exact location about there, and I'm going to say get rid of the left back curb 2. Alright, you see how that disappears? This bit of curb we're going to fix by using the string to replace it. But that's done, so I'm going to go to this next one here, and I'm just going to copy this entry, and really I'm just changing the chainage range. So I'm going to cut from here to here. Okay, so that stops the dish where I don't want it to be. And then I'm going to cut in here as well. Copy. As I say, if you weren't pushing right up to the dish could continue on. You wouldn't need to suppress it and reinstate it like I am. One more copy. And just change the range of this. And I'll just show you the model of this just so that it sort of makes sense on what we've just done. And the last one's here. That one's already good. I need to do that one. Okay. Alright, so if I just update this model, what you'll see in Model Viewer is that there'll be places where the back of the dish disappears, and that's to make way for the fact we're going to have a string sitting in here. Okay, so now we need to design this string, right? And it needs to be an independent string. We can come back and use it to adjust cross sections, but ultimately you'd only do that in order to get your cross section plot looking nice. What we need to do now is to consider this to be its own string doing its own thing. So let's set that up. So what we're going to do is to make a string out of this. So we go to the profile string command, and we click in here to make a string. I'll just be real lazy here and say 0.2 and 1 to get a nice sampling. If you're going to plot a long section of this, don't do it this way. Use add extra sampling. I am going to put a template on this. I do actually have a barrier curve only on the left-hand side, and that's what I want to run all the way from this alignment. So when I click OK, I've now got a string that I'm playing with, right? Now this string is initially draped onto the natural surface. It's pretty awful. What I'll do just to get us started is I'm going to drape it onto total model, but then we're going to do something better than that. Okay, I will apply a fitting. Okay, so this actually sets up a vertical design that in general copies the total model surface. Now that's not very good because it kicks up the curve here and does all sorts of awful things, but it sort of gets it started. You can certainly snap your start and the end onto the total model by using this and not doing a fitting. But we've now got a string in here. Let's quickly build a model out of this so we've got something else to look at. So what we're going to do is to turn off the display of auto model. So we're just going to turn off the display of that. We're going to make a new model using Model Builder. And we're going to link it to auto model. So when auto model changes, the knuckle moves, curves get installed or whatever, they'll get added to this model. So this is the final surface model. And in Model Builder, it shows you all the strings that you can work with, and we want to tick on the parking bay. Now the parking bay strings are there, but we don't really want the curb strings of the road where the parking bay is because it's duplication. So we're going to edit the lawn street, and we're just going to trim out where that where it conflicts with the curbing that we've already got. So we're just going to pick. So we're just going to pick this location here, and we're going to pick the other end. I'm going to say, look, from that one end to the other, we don't really need to see the top of the curb on the left, and we don't need to see the back of the curb on the left. Now, if you think about this, we've got a lovely dish string finishing. We've got a lovely curb shape finishing for the parking bays. From a plan perspective, it's beautiful. There's no overlaps. It's singing and it's dancing. It's looking exactly the way it should look. So what we do with this is we build a model. So there's a model. One big issue we've got really is with the elevations, but let's go and have a bit of a think about that. If I go into Model Viewer now, I can come into here and just change the reference model to the built model. And what I'm going to see now is that it's going to connect those bits together, join the dots, and sort of show me how that looks. Now there is a little bit of argy-bargy going on here, but the real problem is the elevations, right? So the problem is that my design for my parking bays actually don't touch the road elevations. From a modeling perspective, it's all in there, it's stringing up, it's connecting, things are cut out where they should be cut out. If I look at the back here, I can see that there's some elevation difference to the footpath that I need to address. But in terms of the model's all connected, and it's handling quite happily the reversals and the changes that are going on. Okay, getting the levels right. All right, so here's the cool thing to know, right? You have a command called surface extend. Now, we actually created a little code in here for L-Bay, if you remember, and that code actually runs all the way down the road, okay, the whole length of it. What we can do is make use of that and create a surface that extends L-Bay out, right? So from about this change here, we're going to push L-Bay out. So from around 170, we're going to push out L-Bay. And actually, we'll do that further back. We'll do it from, say, 160. So what we're going to do is make a dummy surface, a draping surface. Again, if you haven't done this before, it's actually very powerful. If I'm down here around the 300s where my parking bay is, that's what I currently see on the road. So obviously I haven't killed the curb out of the road cross sections. I've killed it out of the model, but not out of the road cross sections. Now, in order to get levels right for the parking bays, what I really need to do is to somehow get a 3% from the back of the curb out all the way out. And I do that by extending L-Bay. So there's a tool in here called Surface Extend. And what it does is it lets you build your own models by taking a road, taking a code. So let's call this one Extend Out L-Bay. You then put in your range, so 160 to the end. And on the left, we want to extend out from L-Bay. So that L-Bay code, we want to stretch that out. On the right, we don't really care, so let's go with RBAT. And we're going to extend that left side, let's say 10 meters. So once I build this model, there's actually a new surface that gets built. Okay. If I show that on the cross sections, hopefully it will all make sense. I'm going to show the surface of the extend out. So that's extending out at 3%. Perfect to drape onto, right? I can drape my parking bay string on there and then make changes to it, okay? Keeping in mind that I want to leave it draped onto the surface for part of the way. So let's get in and do that. So I'll just open up Model Viewer again. So if I just crack open that string, I'll just make this part size again. Thank you for everybody's patience. I understand I'm so excited I'm running out of time, but okay. So the levels out around here aren't particularly good, and if I open up the vertical grading of this string, the parking bays, right, the issue is that I don't really know what are good elevations to use here, okay? I can drape straight onto that string. Just so you know, you can also add a design constraint and show that surface. So there's a design constraint called use profile code, and that actually lets you show the levels of a surface. Surface display, I'll call this. I'm going to show the extended out L-bay. I'm going to do that for my current string, for the center line, the whole way through, and I'll show it with this color. So if I just update the display here. Okay, you see that purple line? That's actually the elevation of that extended surface. You can snap onto that. You see the snap option. You can snap straight onto that and create IPs. Now, this tool here, Compute VC, it automates the whole process, right? It does an automated drape. So what I'm going to do is I'm going to change the rule of this. Instead of hitting up total model, I'm going to hit up this extended out left bay. And I'll leave out the first meter. And what I'll do for the first meter is I'll tell it I just want an exact drape onto the extended out bay, no fitting. Once I click on apply and exit, you'll see that it now does a best fit, closely matching that extended bay. You're the designer, right? You get to change this, you get to set up the levels. This is just helping you get started. But what we've done is we've plugged it down so that it's more reasonably positioned relative to the design surface. And what you can see now is that the parking bays are connecting much more nicely against the existing road edge. Now, threads is your friend. If I move my road up and down, because I've got a rules-based design here, I could use the threads. If you didn't see it a couple of weeks ago when we did a web session on it, there's videos hanging around on YouTube. Suggest you have a look, but threads would allow me to automate the reconnection of this vertical design when I change my road design. But you can see this is set up nicely connected. The footpath is a little bit high and a little bit low. What we would do with the footpath, and I won't do it because we're just out of time, I would make a string out of the footpath, and I would use this same command to drape the string onto that extended surface with 150mm kick up, which would put it exactly behind the back of the curb vertically. I would then use the profile control on DeLawn Street. Now, if you want your cross sections of DeLawn Street to marry up with this design, you can have that happen, but not with this wraparound part. Okay, and the way that happens is using copy codes. So I'll just quickly do that, and then I just need to show you, just in a quick moment, what to do with your cross sections. And again, I apologize for going over time here. So I'm going to add in another variation called copy codes. Now, if you haven't used this before, what copy codes does, I'll just turn off the display of the surface for a sec. What copy codes does is it lets you marry up not just the string from one point to another, but the full cross section of another string. So if we think about what we've achieved here, the string for the back of the curb the string we've designed for the parking bay has two codes on it, a top of curb code and a back of curb code. And our road itself actually has a top of curb code and a back of curb code as well. So most of you are familiar with mapping a code onto a string. Copy codes lets you map the codes of a string onto the codes of your current string. Okay, so we can basically take the parking bay codes and use those to manipulate the bay code, the top of curb code, and the back of curb code of this cross section. This is only important, okay, really only important if during cross sections, when you plot cross sections, you actually want the subgrade to extend out. Okay, if you're not plotting subgrade, I wouldn't worry about this step. But copy codes, you put in your range. Okay, so we'll do it from 160 odd to the end, and we're going to copy information off the parking bay string, and we're going to get the full position of the parking bay string. And really what you're doing is you're saying, look, take the current bay code and give its position based on the center line of the parking bay string. Take the top of the curb code of the road and set its position to match to the top of the curb code of the string. Take the back of the curb code and set it to marry up to the back of the curb code of the string. When I update this, what should happen is the codes should push out. So these codes now are getting their position, full position, off that design string, okay, of the parking bay. That sets up your subgrades. Your subgrade would look sweet. Let me just quickly show you what you would do with your cross sections. So if I just run up the cross section plotting. Now, one of the things with cross section plotting is by default, the software talks to you about just your current road cross sections. So it's just talking to us here about DeLawn Street. All right, so when you have a look at this, you can see that it's stretching out this parking bay, the first one, beautifully, because that's based on sections. You can see what it's done with the Knuckle, and we don't have the rest of the Knuckle part, because this is just DeLawn Street by itself. And you can see up the top end here that because we did the copy codes, the subgrade doesn't look too bad. Okay, I'm just going to increase the width of the sections here. Just so we can see the full cross-section shapes. Okay, now the issue here is that we're not actually capturing the full return of the model. Okay, so what you do is you actually remove the design surface, which is just the lawn strip by itself, and you replace it with a CSD built model. So for all of you who have wished that you could see an intersection where the curb returns are rolling down into intersection, or take the section lines for a cul-de-sac, this is how you do it. You add a CSD built model, and all we have to do is tell it what model to use. Okay, and we can also tell it what codes to plot. So I actually do want the back of the curb, and I do want the left bay. So I've got the dish code and the bay code. I do want to plot those. I'm going to set the widths to match the sections, and you always turn on as trimming. I'm going to draw that on this layer. You can show crossfalls. I'm not finding these to be as consistent as the other ones, but we are working on this. And I'll just quickly turn these on. Okay, this line work is the line work of the actual model. Now, where that makes sense is that this cross section here changed to 60. Think about this. Change to 60, we're slicing through that 60-degree angle bay. So we have the edge of the road, we have some nature strip, and then we have the back of the 60-degree angle bay, and then we have curb again, and then we have the footpath. All right, so it's actually giving you the proper cuts of the model. The subgrade looks pretty reasonable. You would need to draft in here, but for the parts where it doesn't wrap back on itself, because we used copy codes, we've got a pretty good subgrade representation in front of us. And that's what I wanted to highlight about the cross sections. You want to plot a model, all right, if you're going to do this sort of stuff. If I go back and just have a look at change to 60, just to give you the rationale of where we were. What change is this? Change to 60. Here's the change right here, this line. That's what we were slicing on our cross sections. All right, we went up the curb, down the curb, up the curb to the footpath. All right, so just in terms of notes here, cross-section plotting, you can control the labels with filtering. If you want the subgrade, use copy codes, which we did, and you want to add a model. Okay, you want to reference a CSD built model. You'll notice in that cross-section plotting that you can also reference in a straight surface. So if you've designed a surface in Civil 3D without using Civil Site Design, you can still use Civil Site Design to plot it, and all you do is you filter the offsets. Okay, there's some great filtering options you get a really good result. So lastly, I did talk about threads. So this is up and coming functionality. I didn't have it in my 2018 because I only just put 2018 on. Threads allows you to automate processes. So when we redesigned DeLawn Street, we could have clicked the thread and it would have updated the redesign of the parking bays and updated the model and updated the cross-section plotting all at once. If you missed the session about threads, here's a YouTube link. Just click on it. It will jump me into a lovely YouTube, and I'll turn off the audio, but lovely extended webcast showing you threads from ground up. Okay, so that's really what I wanted to show. Hopefully everybody got something out of that. I am open to any questions people have or comments. You've got a chat and a question area. Does anyone have any questions about what they've seen? All right, well, I don't see any questions coming in, so hopefully you're all stunned with excitement. If you do have any challenges or questions, pop into our support system. If you've got any issues where you're trying to do what I've shown. This video has been recorded, so it will be poked up onto YouTube and available via the welcome screen. So keep your eye out for that.